So we're midway through our TicTacToe project, and we're going to discuss what we've done so far, just to make sure everyone's caught up and aware of what's up next. So first of all, I'll point out that we're using two different files, and they're in the same package. Essentially, it's a folder, but Java is really convenient where files that are in the same folder or the same package get bundled together like this. It can get a little bit complicated and sometimes a little frustrating dealing with how NetBeans in particular sometimes auto creates default packages, and files can get a little bit disorganized. But note that we have a package and the two files are connected, and that'll be important as we start to create a board. So one of the files is a new class, just like how we always launch our main class inside we launch our main method inside of our default class. You can create your own types of objects, just like how string and an int and other data types. We can create our own custom data types, our own objects with their own properties and methods. Like a board has properties about whose turn it is, and it has some functions so whose turn it is, and it has some functions to play the game. And then we have our launcher. Essentially what this is it provides us a menu, and if we want to play the game, it will then create a new board so we can do that. Okay, so let's take a look at our launcher first. So we're at we have the main method offers us a menu, and then depending on what the menu hands back, we'll have different cases if menu returns the number 1, 2, or 3, and there is no case for anything else, so we'll only be able to handle 1, 2, or 3. But if you don't pass 1, 2, or 3, nothing will happen. It will go back to the top of this loop, and you'll be asked, the menu will display again and give you these 3 options. So pretty handy. And then we'll also notice that it says welcome first, and welcome just executes a loop. A lot of the code that we're going to see here is inefficient, but it shows us new concepts. For example, this switch, there are so many easier ways of doing this, but this is an opportunity for us to look at how a switch works. A switch, instead of having a lot of if, else if, else if, else if. So if menu, so we can store menu into a variable. So let's say int user answer equals menu. When the menu runs, we can store that answer, and then we can test it. We can say if the answer is equal to 1, do this. Else if the answer is equal to 2, do this. Else if the answer is equal to 3, do this. And that would be a lot of if statements. A switch is just a little more elegant way to have a series of cases all in a row. Okay, and same thing with the loop. Here we're looking at the modulus operator, which allows us to test to see if something is even. If it, when divided by 2, has no remainder, then I'll do that. On the odd ones, it'll do this, and when the counter, when our increment is equal to 2, then it'll print this out just once. Okay, now our menu creates a scanner. We've talked about that ad nauseum. It stores what the scanner requests into a string called input, and now we look at a complicated new concept called an array, where it's just essentially a list of items separated by comma, all of the same type, string, and so string and these brackets indicate that it's an array. And now we do a couple complicated things. We do 2 different types of loops to iterate or traverse through all of these items and test to see if any one matches the input that the user said. So we have a bunch of different options for if the person says, no, I don't want to play a game, and it'll go through all of those. And then we have another one that just goes through a counter. So it will go through the index from 0 all the way up to 1 short of the length. So this is 1, 2, 3, 4, 5, 6. So it'll have a length of 6, but the last index will be 5 because this first index is 0. So we're dealing with 0 indexing. Okay. If you have any questions there, let me know. I'm just going to move along and we'll head over to the board. So if the person had said yes, they do want to play, menu would have returned the number 2 and the case 2 would have run. We would have created a new game and instantiated a board object into this variable. So over here, and if those terms don't make sense to you, you've got to come see me and talk with me so we can make sure that these terms are comfortable for you, so as we start to build on these ideas, you're comfortable. Okay, so the board, we have instance variables, and they're private, which adheres to a concept called encapsulation, where we keep our variables, like our passwords and other things, our private information, protected, and the only way to access the actual items on our board is through methods that will allow us to interact with these private elements. So that idea of keeping your instance variables locked down and only accessible through public methods that allow you to, see, none of these are public, so we don't really mess with them too much. But that's because the whole game runs inside the object. We don't have it interacting. All we do is call the game here once and we shut it down. So we don't really have to have outside code editing whose turn it is and editing what board it is. So we're allowed to keep all of this private, so everything is locked down. But if we did have some items being able to be accessed through methods, that will then interact with private and lockdown variables. That's a concept called encapsulation, and that's important. Okay, we'll keep learning about that as we go. This right here is our constructor. It's what automatically runs when the board is created. Right now, this is our preliminary game loop. It's roughly completed. As long as the game isn't finished, we'll show what the current board is. If it's my turn, I'll run the my turn method. If it's not, I'll run the computer's turn method. And afterwards, we'll run back and do it again. So pretty much a simple game loop. It will stop as soon as the game is finished. And that's while not is finished. Okay, this is finished is going to be your biggest assignment, is trying to check to see what all of the possible game-winning situations and see if anyone has won the game. We've started looking at my turn, which is pretty simple. We'll create a scanner and we will ask the person for a number and we'll take an integer, and if the number is not correct, if it's not within the certain range and the board is if the isn't in an available spot, we'll go back and repeat and ask them again. But if it is within the range and the spot is available, we will set that board position to an O. The user is O, the computer is an X, and then we will break out of this loop. So we will then mark it as no longer our turn, and because we've just placed it, and it will return back up here, and then we'll check to make sure we didn't win. We'll print the new board with the player's turn now, and then we will allow the computer to go. The computer will just draw a random number. This random number is between 0 and 1, and so we'll multiply that by 8. So if it comes out to 1, then we'll have 8. If it comes out to 0, then we'll 0 times 8 is 0. So it'll randomly draw a position on our character array, and then if that's free, it'll fill it in as an X. If not, it'll draw another random number and try again. So it'll keep on going until it randomly draws a number that is acceptable. And then we switch the toggle back, so it is the player's turn again, and no longer the computer player's turn. Okay, and lastly, our print board. Our print board is going to start at 0 and is just goes into the board's length and will print out each character in our character array. So we'll print out the character. So this counter, we named it X, which is not to be confused with X's and O's of TicTacToe, but it's just our increment. So we'll start at 0 and we'll go up to, but not included. So the length of a TicTacToe board is 9, but we will go up to 8 because the first one is 0. So 0 to 8 is 9 characters. So now, if the character is the last one, we'll just print out a space and we'll do a line break. Otherwise, if the character is evenly divisible by 3, if we add 1, so every third one we'll add in a line break, and so that way you'll have the first 3 characters a line break, the next 3 characters a line break, and then if you're not the last item and you're not a third, you need a line break, then we'll just put a single pipe in to separate each character. Cool. So that's what we have so far. What's up next is we need to add in a little bit of try-catch. So in case a user enters in a word instead of a number, we can prevent the app from crashing here by using a try-catch. We need to layer that on. The computer player's turn, this is going to be an optional extra credit assignment to make the computer play more intelligently. And then our next big assignment is for you guys to check all of the possible game-winning scenarios in order for us to see if we've got a tie or if there is a winner, and if there is a winner, to declare that winner. Okay, so hopefully you're all caught up now. If you have any questions, please, again, let me know.